Okay, so I just read about this crazy CPU design that uses a linear feedback shift register instead of a typical program counter. How wild is that?
Seriously, it's like a whole new way of thinking about CPU architecture. I didn't realize an LFSR could simplify things that much.
Right? It's all about saving space, especially on hardware that has limited resources. Imagine saving all that complexity.
Exactly. And the fact that on an FPGA the benefits might be minimal because of built-in carry chains, that's a surprising twist.
Yes, when I first read that, I thought it was going to be a space saver everywhere, but not necessarily on FPGAs.
It's pretty cool that LFSRs have historical significance too, like in 7400 series ICs. They're old school yet cutting edge.
Totally. It's like looking at classic cars that are suddenly retrofitting electric engines.
And here's something that gets me. This CPU uses a forth interpreter. Do you ever think about how forth relates to hardware design?
That's a great connection. Forth is so low level, it really gets you into the nuts and bolts of CPU operation.
And the fact that it starts executing from address 0. That's a risky design choice, but it makes sense in this context.
Right. It's like kicking off a race without checking your gear first. But there's no safety net if it locks up.
Haha! That's a good analogy. Plus, did you see the instruction set? Only 16 bits per instruction.
Yeah, it seems limiting, but it's probably all about efficiency. Simplifying an instruction set can lead to faster execution.
Exactly. But can you believe they omitted an add instruction? That sounds like a big miss for forth commands.
I know, right? It's like saying you can make a sandwich but forgetting the bread.
And the way they've structured the instruction layout with bits for indirect addressing, that's clever.
It's fascinating how those bits can dictate whether you're reading an address or a value. It's like a logical switch.
Right, and it makes you realize how everything in computing is about managing what you specify and how.
It's all interconnected. Furthermore, transitioning from intended to actual address space is intriguing.
Agreed. And did you see the potential for dual-port versions? That could really speed things up.
Exactly, though it means consuming more resources. It's a balancing act like deciding on a sports car versus an SUV.
Oh, and what about the potential for creating 7400 series ICs? That could be a whole new frontier.
That gives me chills. Building something tangible with classic tech in a modern application is very appealing.
Right? It could be like breathing life into vintage tech. Sometimes the classics have a lot to teach us.
For sure, and the whole idea of using LFSR for test vector generation, such a smart way to leverage old methods.
Absolutely. It's surprising how useful LFSR technology is beyond just CPU architecture.
And the implications for memory mapped I/O? Wow, that changes the game for hardware interaction.
Yes, learning how to decode addresses for multiple peripherals is like figuring out a big puzzle.
Oh man, and there's a potential for a collaborative environment between multiple chips. That's so inventive.
And they could share input. That horizontal communication could revolutionize how we think of computing cores.
Think about it. They could be giving each other tips like seasoned chefs in a kitchen.
Haha, exactly. It could lead to such smarter designs. Makes you wonder how far we can push this.
For real. And incorporating parts of the CPU for FPGA customization, that's just pure brilliance.
Totally. It's like tailoring clothes to your stature, making the tech work just for you.
Wow, where did this exploration take us? I am amazed by all these layers within a simple CPU.
Me too. It's lovely how one design sparks so many ideas and opens doors we hadn't even considered.
So, with all this, what do we think the next big step is for this kind of tech?
I think it'll be about optimizing those instruction sets and figuring out the best hardware configurations.
Exactly. Plus, merging classic and modern tech could yield incredible new innovations.
It's this fascinating push and pull between the past and future. I'm excited to see where it goes.
Same here. It really gets you thinking about the future of computing, doesn't it?
Definitely. It just reinforces that great ideas often come from revisiting the foundations of our tech.
Absolutely. It's like a cycle of innovation. Can we take lessons from history to inform our future?
Exactly. It's all about being curious and daring to explore the what-ifs, just like this project.